Today for the keynote we have Michiel van der Meulen here sitting in front of us. He is a geologist from Utrecht University, joined TNO in 2003 and had some leadership positions in the TNO Geological Survey of the Netherlands. And currently Michiel is Chief Geologist at TNO Geological Survey of the Netherlands. So what Michiel will do is he will give a broad overview of land subsidence in the Netherlands, and I'm happy to give the floor to you, Michiel.
Please. Oh, it's there. Good morning, everybody. Let me see how this works. Well. Would somebody reboot me? There it is. Okay, so I'm Michiel van der Meulen. Thank you for the introduction, Gilles and Peter. This here is Rotterdam, the gateway to a very low subsiding country, which is hosting this conference for reasons outlined by Gilles. I will discuss subsidence in the Netherlands in broad terms. Many aspects will be dealt with in several presentations by colleagues of the institutes that Gilles mentioned earlier. And when I prepared for this lecture, I remembered that I actually taught subsidence as a PhD student. Imagine a borehole of marine sediments, for example. Imagine that you sample and determine the depth of deposition of the sediments and the ages. Well, if you do that, you can generate a curve that shows depth or elevation, and below the sediment surface you can plot the amount of sediment that accumulated. If you correct for compaction, you would arrive at something that I would have called subsidence in those days, and which we unraveled to arrive at conclusions pertaining to tectonics primarily. Land subsidence, flooding, etc. were merely the unfortunate byproducts. I didn't consider those at all because I was a geologist and I didn't care about people who were not there in the times that we created those, for the times that are represented in plots like these. So for geologists, subsidence is a matter of plate tectonics, of heat flow. Heating implies uplift, cooling implies subsidence. Isostasy, balance between the cross-balancing itself out when it is loaded. And talking of loads, we consider, of course, sedimentation, erosion, because it shifts mass. And the same happens when you glaciate or deglaciate. Those are the processes that you would consider as a geologist. Well, subsidence to the general public, that would be land subsidence, is something else. They would think of adverse ground conditions, building damage, flood risk, that is caused by people or some mystery. And we are going to discuss several of those mysteries at length during these days. Obviously, humans cannot interfere with plate tectonics, not yet. But we do tamper with crustal volumes and the distribution of mass. And this may sound far-fetched, but let's consider some fun facts. This here is a graph that shows the use of aggregates, which would be sand, gravel, crushed rock, granular material used in construction. Never mind the details. You see that the annual consumption can be as high as almost 300 million tons per year. And is this a lot, or isn't it? Well, first, it equates to about a standard sandbag per person per year in this country, which is definitely more than you would eat. In fact, it is a lot. But what really amazes me is the fact that if you divide the total volume of Holocene sediments by the duration of the sedimentation, then you end up with a number that is significantly lower than what people shift around in this country. A mere 30 million cubic meters per year, or let's say just over 40 million tons. Now that fascinates me. Humans, and perhaps especially Dutchmen and women, we love sterilized sedimentary environments. So what are those? This is a map that every Dutch person will recognize. You see colored areas which are enclosed by dikes or dunes, and within each ring, we call it a dike ring, there is a certain guarantee of flood safety expressed in a chance of flooding per many, many, many years. If you take a geologist's point of view, then you would consider this a sterilized sedimentary environment, because keeping water out implies keeping sediment out. And actually, Gilles told us that we have been creating these rings for 1,000 years now and maintaining them. And there is 13 cubic kilometers of unused accommodation space for sediment that never made it to our lowlands. This is part of the reason why they're so low. So a lot of this sediment was flushed out to the sea, and in recent years we helped that process a little bit with dredging vessels, but that sediment that never made it. So we suspended a process that used to maintain the elevation of the more pristine lowlands in this country. And it gets worse, because behind the safety of those dikes, so sediment didn't make it, peat stopped growing, but actually our water management practices cause peat to simply disappear. Above the managed groundwater table, peat will rot away, you get a volume decrease, and this produces subsidence. So subsidence behind very safe walls, and it goes largely unnoticed. We notice as a community, but we've been using the Dutch lowlands as if nothing is happening. Crossing this line that Gilles just showed, we moved from elevations above to elevations way below sea level. So water management causes the lowlands to sink in rates that would be expressed in millimeters per year. But as we have been doing this for quite a long time, the end product can be expressed in meters. I will show you later on. It is a process that, well, the typical time scale is that of centuries, and the scales are regional to supra-regional. It affects the entire coastal plain of the Netherlands, the entire, well, this is a small country, but even so. And it is difficult to measure, actually. We don't measure it a lot. We can measure buildings, the built environment sinking, but sinking peatlands is another thing. And I think there will be there will be some presentations about that. We can make scenarios and we can do predictions, but as this is subsidence that we cause ourselves, it is a difficult thing. And obviously it affects flood risk and land use. So then there is, in the present situation in the Netherlands, we have gas and salt mining causing subsidence. Typically in the millimeters per year range, the same sort of rates that are produced by water management. Decimeters rather than meters in total, because we are not mining for centuries, we are mining for decades, and the scale varies between what I would call local and regional. It is actually it is possible to predict subsidence resulting from gas and salt mining, and to some extent it is monitored, obviously, and it affects surface water management to some extent. Here you see a graph. Just notice the big red blob. in the upper right corner, that would be the Groningen gas field producing subsidence. Some of these smaller red blobs would be salt mining. And then there is something that, well, I'm taking a very broad definition of subsidence. We also cause subsidence by loading the sediments in the Dutch lowlands. We put sand before we build stuff. The sand will compact whatever is beneath that. The rates can vary between millimeters and centimeters per year. And the main problem there is that the subsidence occurs differentially. The scale can be extremely local. You can measure it. Subsidence in the built environment is well measurable. And this affects the stability and integrity of constructions. So this is what happens in terms of subsidence in the Netherlands. There's more. There would be karst in Limburg, caving in of former mine shafts, but these are the big processes that affect our lowlands. So let's have a look at the geological map here. It is new. You can actually purchase it with Kai Koster downstairs. And I'm asking you to not consider the details because there are lots of them. The dark brown colors indicate peat. And you see in the north, do I have a pointer? Yes, I do. Here you see peat near the surface, and here you see rings of peat that encircle, let's say, beige areas. And this is where peat has been mined, and let's say the pre-peat Holocene marine deposits are exposed. These are very deep areas. And peat, it can oxidize, but it has also been removed. And all of these processes have contributed to the present elevation of the lowlands. Here you can see that peat mining has been taking place primarily, observe the, the cross-section. So peat has been mined where peat domes have been present, so where the elevations were actually a bit higher. That peat has been mined away, leaving us with these big holes, let's say, that I showed on the geological map. And then there is this process of peat oxidation producing subsidence. What fascinates me here in this image is that in 1,000 years we have produced up to 8.5 meters, give or take, of subsidence. It is a lot. We are typically looking at current and perhaps future subsidence, but in the Netherlands we have had a lot of subsidence already. And if you take a look at the end result, this is basically the same graph that was shown earlier. And I've made the deep polders, so the peat mining sites primarily, and other polders. They're shown in gray, so these are the deepest areas. In green, you have the ramps towards these very low areas. So this is where we live now. The deepest areas are 4 to 5 to 6 meters deep. So what would happen, we asked ourselves, if we would continue current water management practices? If we would continue to drain and drain and drain the peat and simply let it rot away? And just watch. So you see that these gray areas have become much bigger. I'm going back and forth so that you can see and... Well, it doesn't work. Anyway. It works. Here we have our elevation back, and here we're losing it. So we could be creating these huge bathtubs under conditions that are dire as people perceive it, because in the meantime, the sea level is rising. So what do people do with this perspective? Here you see a map drawn by Utrecht University, giving a very, let's say, a future scenario on the right-hand side of the image of the slide. in which we have lost most of the lowlands. There are some remnants of the current coast. It is a scenario exercise for an unspecified moment in the future. Because we're starting to consider the possibility that our lowlands might not be maintainable in the long term. We have to start thinking about that. What is very relevant is that in this image here, in Dutch it says, Dutchmen think that we will be underwater in a century. How realistic is that? That is what the headline says. It is very significant that they show an image of the Great Flood of 1953 because people think that between the now and the here and the submerged future, there will be a disaster rather than an organized retreat or whatever. So they project a disaster in that scenario. Whereas other people argue, such as this gentleman TISOLS, he says, the water is coming, but don't be afraid, we'll manage. So these are two extremes. So people think, we should retreat, we should simply give in, and others say, well, we'll manage. Interestingly, this is an image, again, of the flood of 53. This is deeply ingrained in our cultural archive to think in terms of disasters like this. This is what Dutchmen and Dutchwomen will make them wake up screaming during the night. An image like this, a dike breached, water flooding into the lowlands. And interestingly, this is a painting of the St. Elizabeth's flood in 1421. You see an almost identical waterfall. And what fascinated me here is that this particular flood has made it into, let's say, history as a single catastrophe that killed countless people and destroyed lots of land, while a historian recently argued that it was actually a gradual process of deterioration, and there was a flood that was like the last drop that made the bucket spill. We seem to be projecting catastrophes, floods of biblical dimensions in the past and also in the future. But I think catastrophism is not very helpful here, because if people think that subsidence will cause a single flood that will take us by surprise, I think that is not a very helpful way to look into the future. And this should be the context in which we consider, measure and predict subsidence in this country and maybe other countries as well. To go back to these two extremes, so there are people who say, well, whatever happens, we will manage the water. And typically I will ask, I'm sure, because we are very good at it. We are already living way below sea level and we seem to be doing fine. What about after World War III? Will we be doing fine then? Will we have the funds to maintain the systems that protect us? Because if we are considering these long time scales, we would need to allow us to consider a major economic downturn, a war, or whatever may impede us from managing the floodplains, the coastal lowlands, in the way we're used to. And to those people who say, well, we should just give in, we will need to evacuate the Dutch lowlands. Okay, but when and how? I've seen a presentation by an architecture agency firm, and they announced that, well, we will not build below sea level from now on. Well, at a lifetime of a couple of decades of a house or building, you can just put it as low as we go in the Netherlands, it will be fine. But we need some time perspective here. So, so my final thoughts bear to that perspective. What we plan and do now will matter in the future. For example, we have a housing shortage in the Netherlands, and we have a very diligent minister who is responsible for that, and he plans to build, I think, 100,000 houses somewhere. Where will he do that? Will geology or will subsidence, sea level rise, will that be taken into account at all? The individual houses and buildings might not last that long, but the infrastructure that will create will have a life of maybe a century. Well, what will happen in the course of that century? So what can we do as a community? Well, we need to measure subsidence. Subsidence is fairly well measured already, but I'm looking at Ramon Hansen, who is looking, well, who's seeing room for improvement, especially in those grasslands, in those green meadows that are subsiding in a largely unnoticed way. More measurements are needed in order for us to be able to model subsidence and to predict it. Is that all? Well, it's actually difficult because predicting subsidence due to water management, you would have to predict the behavior of water managers as well. Because what they do, they manage the water and the land surface will simply follow the water table. So that is actually more difficult than modeling subsidence as such. We are typically a community, as we are gathered here, of geologists, geodesists, geographers, engineers, and we have a blind spot for the economics associated with subsidence. I'm working now with a spatial economist who is considering the value of these very vulnerable lowlands. When he sees images of the Netherlands being evacuated, he will laugh and say, well, cities never die, which holds some truth because you can actually throw an atomic bomb or other bombs on cities and they will grow back again. And he argues there's value in the agglomeration that we will not be able to let go, let's say. So it's true, but how do we account for that in scenarios for subsidence, in scenarios for water management? It's actually, I wouldn't know. We're figuring that out right now. And with all of that, with what we know about water, about subsurface, about water management, etc., about mining and the consequences of that, we need, and I'm talking about we, the Dutch, we should not panic, but we should make scenarios. Because drawing a map of the Netherlands being half blue, half submerged, that is not a very interesting map. What would be the map just before that? What, if so, what would be the lands that we would be vacating, if that is going to be happening? That's far more interesting than if we let water, than the result of us letting water come. And stressing it again, we need to consider the long-term consequences of our current plans. One of the difficulties of working as a geologist with any non-geologist is that we consider by nature longer timescales. A century for me and my colleagues is very short. I'm actually more comfortable with the millennial timescale. And we are used to looking back in time, but when we flip that, we are not, we will be inclined to look quite far in the future, into the future. Decades are very small. Centuries is more comfortable, and millennia is, well, is what we do. But all the non-geologists are not used to considering those timescales. The spatial economist I mentioned is, they look a couple of years, decades at most, and that ahead, and that is very far-fetched for him. And the same goes for engineering. But we'll get there. We somehow have to put, let's say, what we know together and have an educated guess of what might be happening and decide where to build what. If humans interfere with volume and mass, they shift sediment around, they deplete gas reservoirs, and they cause subsidence, maybe maybe there's a solution in thinking in terms of volume. If we can remove it, can we put it back somehow? We once did the math, and we could, theoretically. But should we? Well, I'll leave you with that thought. And I would like to thank you for your attention. It is useful.
Any questions for Michiel?
Yes.
You didn't mention climate change, and you mentioned World War III or so, but I think the climate change is much more urgent at the moment.
Yes. In fact, I did mention climate change as a factor that via deglaciation affects the water level. Climate change in this context affects mass distribution and in that way subsidence. This is, let's say, a gradual process that needs to be taken into account, primarily via sea level, and perhaps also in the via drought, oxidation rates, that sort of thing. Obviously, it is there. It is, let's say, the background process that needs to be considered. Yeah.
More questions? Yeah.
I have one question. You mentioned that in the North part, for the gas submarine, the serious less happens there. I wonder if your companies have ever had any control or generation for that kind of fast energy.
So the question is, what kind of control do we have over the effects of mining? Well, I see colleagues who are deeply involved with that. So an operator in the Netherlands has to submit an annual plan for extraction, whatever they extract, gas or salt. And they have to give an estimate, they have to model the substance that comes with it. And and that is a condition of the license they have to mine. And those calculations will be, let's say, reviewed by my colleagues. They will be reviewed by the state supervisor of mines who considers mining safety. And there will be monitoring to see whether the effects are within, let's say, the limits of what is predicted. So it is fairly well controlled, I would say. And yeah, does it answer your question? Yeah. Ramon.
Yeah, thank you very much for the fantastic presentation. I was wondering about the evacuation scenario that you suggested. So we now see in Indonesia that people are changing, let's say, Jakarta to a new city. So basically, the scenario of moving cities is already taking place in other places. I think within that, you're as close to the government as we can get. So how serious are the discussions on the governmental level to consider that particular scenario?
Well, it is interesting that you mentioned the word evacuation, because that, for me, connects with disaster. Yeah. But let's say a planned retreat. I don't know, because I've discussed this personally with the staff of the Delta Commissioner, and they are very interested, but they typically don't consider that far a future. What I also know is that in the fifth policy document considered spatial planning many years ago, that was the first occasion when somebody considered, let's say, the possibility to retreat, and it was discarded as something, well, to not consider in spatial planning at that time. Different times, though. And I think now we are preparing ourselves for scenarios like that, but we need to chew on it collectively. We have to separate disaster and land use planning and look into the future with an open mind, if we can. It is difficult because politicians do not look ahead in time as far as it is needed automatically. Yeah. Ingrid.
My
last September, there was an update of the national security assessment. And that update, very first time, the scope was further than the other 4 years ago. So there was a tiny attempt to look a bit further into the future. And I would say that if it's smooth enough in the year, that the next decade of this assessment will consider future various windows much more forward.
Yeah.
So we seem to be a bit on the range. There's some room to be made.
Yes.
I think there's also a difference between a real retreat and not further expand.
Can everybody hear what Esther is saying?
Okay. No, I just wanted to add that I think there's a difference between a real retreat and not further expanding cities. As in the Netherlands, we have the big challenge that we need more houses. So over 900,000 houses need to be built before 2035, if I'm correct. So the question is where to build those houses. And I think, but maybe some people in the room know this better than me, but these will be mainly built in our low-lying soft soil Randstad area, where the cities of Amsterdam and Delft, The Hague, etc. are located. So, so I was thinking of, and also in the Jakarta case, I don't think, you also don't think that, Ramon, I know for sure, but the city will not be entirely left, of course. So, but yeah, so I think there's a difference between that, and it would maybe be good for the Netherlands to stimulate extension of cities at the higher elevated Pleistocene sand grounds.
Yes. And what is relevant about that comment is that you basically stress the gradual process versus catastrophism. We are not going to demolish Amsterdam or anything like that and move it. Or maybe we will, but we should plan for that. But it is a gradual process. And yeah.
I have one question there and then one there.
Thanks. Thanks for a great presentation. I have a question which is a bit related to the one from Ramon, I think. What mechanisms do you have that, the insights that you so generously shared with us find their way into policy making? And do you see evidence that it is happening, and are you happy with that?
In order for us to connect with policymakers, we should have this broader perspective that at least also includes the economy. Because that is, as I said, it is somehow lacking in our thinking as geologists and engineers, etc. While money steers, but this comes with challenges because the money people don't look far enough into the future as is necessary here. So we actually have to figure out the way to do that. But we have to keep telling these things. But also, I think the tone of the message is also important, which is why I actually stressed the difference between catastrophism and something that we will do according to plan. If you don't mention these things, people will project a catastrophe into the future, for sure. And that is not very helpful, because then we will be only managing crisis after crisis, and well, that's not the way to go.
Okay, I have one last question. Saskia, you had a question? I'll give the floor to Jim.
I just wondered about sacrificing certain areas to help other areas. In the gas fields, the Dutch government makes a good bit of money, I expect, from production. And can that area be sacrificed to fund the retreat? Is that kind of planning under consideration, or is that area very built up, urban-wise?
Yeah, it is. The area is very built up, and in the here and now, it is the emotional value of the lands. It is not in our cultural makeup to give up. We had to give up a polder somewhere in the southwest of the country for environmental accounting reasons, and it has been a huge controversy, a huge one, and it was a tiny bit of polder. These things take time. It will take generations actually, but because I noticed that even my children think differently about these things than I do, or Peter for that matter. Yeah, I know him well.
That is true. So we don't say who of the two of us is younger or older. With this, I will like to thank Michiel again, and let's give him a warm applause.